Welcome, fellow cosmic explorers, to a journey to the very edge of our planetary neighborhood. Today, we're venturing out to the eighth and farthest planet from our sun, the enigmatic ice giant, Neptune. Neptune, named after the Roman god of the sea, is a world of incredible beauty and extreme conditions. It's so far away that it takes sunlight a whopping 4 hours to reach its frigid surface. If Earth were the size of a nickel, Neptune would be as big as a baseball. This colossal ice giant is approximately 4 times wider than our home planet. 1 year on Neptune, that's 1 full orbit around the Sun, lasts an astounding 165 Earth years. Imagine living through just 1 Neptunian birthday. What gives Neptune its stunning cerulean hue? It's primarily due to methane in its upper atmosphere, which absorbs red light and reflects the blue wavelengths back into space. But don't let its serene appearance fool you. Neptune is home to the most ferocious winds in our entire solar system. We're talking wind speeds that can reach an astonishing 2,160 kilometers per hour. That's over 5 times stronger than Earth's most powerful hurricanes. These incredible winds whip around the planet, creating vast storm systems. Back in 1989, the Voyager 2 spacecraft, our only visitor to Neptune so far, observed a massive storm system known as the Great Dark Spot, roughly the size of Earth. Much like Jupiter's Great Red Spot, this immense anticyclone was a dominant feature. However, by 1994, it had mysteriously vanished, only for new dark spots to emerge later. This tells us Neptune's atmosphere is incredibly dynamic and ever-changing. Unlike the gas giants Jupiter and Saturn, Neptune is classified as an ice giant. Beneath its thick atmosphere, it's largely composed of a hot, dense fluid of icy materials, water, methane, and ammonia, surrounding a relatively small, rocky core about the mass of Earth. Scientists even theorize there might be a superhot ocean of water beneath its clouds, kept from boiling by immense pressure. What's truly fascinating about Neptune is its discovery. Unlike other planets, Neptune wasn't first seen through a telescope. Its existence was predicted through mathematical calculations in 1846 by Urbain Le Verrier and John Couch Adams, who observed irregularities in Uranus's orbit, suggesting the gravitational pull of an unseen planet. Our understanding of Neptune leaped forward dramatically with the arrival of NASA's Voyager 2 spacecraft in August 1989. This historic flyby provided the first close-up images and detailed data, revealing its turbulent atmosphere, faint ring system, and a captivating collection of moons. Since then, telescopes like the Hubble Space Telescope and more recently the James Webb Space Telescope have continued to provide incredible insights, allowing us to observe its dynamic changes from afar. Like its fellow gas and ice giants, Neptune boasts a system of rings, though they are much fainter and harder to spot than Saturn's dazzling displays. We know of 5 main rings, named Gale, Leverrier, Lassell, Arago, and Adams. What makes Neptune's rings particularly unique are the mysterious ring arcs within the outermost Adams ring. These are clumps of material that defy the laws of physics by not spreading out evenly. Scientists believe the gravitational influence of Neptune's small inner moons helps shepherd these particles, keeping them mysteriously clumped together in arcs named Liberté, Égalité, Fraternité, and Courage, fitting names for a distant, defiant system. Neptune is orbited by a fascinating retinue of celestial companions. As of 2025, we know of 16 moons, each named after lesser sea gods and nymphs from Greek mythology, a nod to Neptune's Roman namesake. Most of these moons are small, irregularly shaped, and orbit far from the planet. Some have highly eccentric, elongated orbits, taking decades to complete a single journey around Neptune. These are often thought to be captured objects rather than forming alongside the planet. But among Neptune's moons, one truly stands out: Triton. Discovered just 17 days after Neptune itself in 1846 by William Lassell, Triton is by far Neptune's largest moon, making up over 99.5% of the total mass orbiting Neptune. It's slightly smaller than Earth's moon and, interestingly, larger than dwarf planet Pluto. Triton is one of the most intriguing and mysterious objects in our solar system. One of Triton's most peculiar features is its retrograde orbit. This means it orbits Neptune in the opposite direction to Neptune's own rotation and the orbits of most of its other moons. This strongly suggests that Triton wasn't formed with Neptune, but was instead a captured object from the Kuiper Belt, a vast region of icy bodies beyond Neptune where Pluto also resides. Triton's surface is a marvel. Despite its frigid average temperature of -240 degrees Celsius -400 degrees Fahrenheit, it's surprisingly geologically active. Voyager 2 revealed a remarkably young surface with very few impact craters, indicating ongoing resurfacing. We see smooth plains, wrinkled cantaloupe terrain, and perhaps most remarkably, dark streaks believed to be the residue from active cryovolcanoes. Yes, cryovolcanoes. These are not like the fiery volcanoes on Earth. Instead, they erupt with plumes of nitrogen gas, ice, and dust, sometimes reaching several kilometers high. Scientists believe sunlight heating dark patches beneath Triton's translucent ice could pressurize nitrogen, leading to these dramatic eruptions. Some theories even suggest there might be a subsurface liquid water ocean beneath Triton's icy crust, hinting at the potential for exciting discoveries. Triton's retrograde orbit, while fascinating, spells its eventual doom. Neptune's gravity is slowly but surely pulling Triton closer. Millions of years from now, gravitational forces will tear Triton apart, potentially forming a spectacular new ring system around Neptune. While Triton takes center stage, Neptune's other moons also have their own stories. Proteus, for example, is the second largest moon and one of the darkest objects in the solar system, so dark it reflects only about 6% of the sunlight it receives. It's oddly shaped, appearing almost like a lumpy potato. Then there's Nereid, known for having one of the most eccentric orbits of any moon in the solar system. Its distance from Neptune varies wildly throughout its long, 360-day orbit, suggesting it might have been flung into this chaotic path when Triton was captured. Despite its incredible allure, Neptune remains largely unexplored. Voyager 2's flyby was over 3 decades ago. As of today, there are no confirmed future missions to the Neptunian system. However, scientists are constantly proposing exciting concepts. Missions like Neptune Odyssey envision an orbiter and atmospheric probe to study Neptune and its moons in detail, with a potential launch in the 2030s and arrival by the 2040s. Another concept, the Triton Ocean World Surveyor, would focus specifically on exploring Triton's potential for a subsurface ocean. These missions would revolutionize our understanding of this distant ice giant. Neptune, the dazzling blue marble, stands as a testament to the incredible diversity and mystery of our solar system. From its supersonic winds and faint, clumpy rings to its enigmatic moon Triton, with its icy geysers and retrograde dance. Neptune offers a window into the extreme conditions and dynamic processes that shape worlds far from the sun. As technology advances, we look forward to the day when we can send new robotic explorers to uncover more of Neptune's secrets and perhaps even find clues to the origins of life in unexpected places. The journey of discovery is far from over. Thank you for joining us on this incredible journey to Neptune and its moons. If you enjoyed this exploration, be sure to like this video, share it with your friends, and subscribe to our channel for more amazing adventures in space. Keep looking up.